Okay, so how do we actually get into space? We use rockets, right?
We do. We don't use ham sandwiches or TNT. And as you said, most of the fuel doesn't go on it. Now, we're going to go over a very simplified way of how rockets work. Now,
Of course, this is rocket science.
yes, this is rocket science, and we are highly simplifying it. But at the principle here, a rocket has four things you have to budget in terms of forces and energy. You have the weight, and this is all of the stuff on the rocket. So not just the human or the satellite, but the physical rocket,
The fuel.
most of the fuel, other bits to make it go. You also have then the thrust, and the thrust is what you want. What we want is to generate as much thrust as humanly possible in a safe, sustained manner, because we can generate a lot of thrust, as you said, if we put a bunch of TNT on it, but then maybe not have any astronauts at the top. Or we can have a lot burn slowly, but then our ham sandwich is going to take years to get into space, and we won't reach there. We also have drag, and this is something that we often just kind of ignore when a rocket takes off. It has to go through the atmosphere, right, Paul?
Yes, and the drag backwards, by the time you're 10 kilometers up and the atmosphere is much thinner,
That's
it's not
right.
so much of an issue. But when you're, especially that bottom few kilometers, you've got lots of weather to go through, lots of air, you have to push that air out the way.
And you haven't been burning as much fuel for long, so you don't have as much speed. So in fact, the effects of drag early on actually could be quite big.
Yeah, but you want to go slowly because drag gets worse. If you've ever tried riding a bicycle,
That's right.
The drag force, the wind resistance is much worse when you're walking. It's actually proportional to the square of the velocity. So you go twice as fast, you get 4 times the drag. And so as you go faster, the drag gets worse and worse. So often those rockets go quite slowly through the bottom few kilometers when there's lots of air. And then once you're up at 10, 20, 30 kilometers when the air's pretty thin, then you go hell for leather.
That's right. And then you have the lift, which is the actual lift of the force underneath your rocket from generating that. So there's a few different things going on in a rocket that we have to budget in. So it's not as simply as let the rocket ignite and we go as fast as we can, because as you said, things can break apart too early. They cannot get enough speed because we generate too much drag, so we don't have enough fuel to get outside. So it's about a series of burning and igniting at the right time and the right speed to get the rocket up. And so when we start actually looking what the rocket works, again, this is a simplified version of one of the Redstone rockets. We have our nose cone, and the nose cone on the very top of every rocket, the very smallest bit, is the actual stuff that gets into space.
That's right. So we talked about 1 kilogram of fuel can't get 1 kilogram into space. And what we've seen is that the rocket is mostly fuel when you take off.
That's right.
And most of that fuel is going to be burnt pretty low.
Exactly.
So you might easily burn 10 tons of fuel to get 1 ton into space.
That's right. Most of this fuel is going to not even get anywhere near and close. In fact, this is often why rockets have stages. So some rockets have one stage where it's just one giant thing that goes in. Those are generally the small rockets because you use up all of that fuel to get most of the way up. You then have second and third stage rockets that the further out you go, you can add a little bit more fuel and then a little bit more fuel to give you those extra pushes.
Yes, and another thing here that it tells you about is that on Earth, when you burn something, you can rely on oxygen from the atmosphere to burn it. So
That's right.
When your car is driving, you carry the fuel, but
You don't have an oxygen tank to help you go faster.
the fuel has to combine with oxygen, which it does inside the cylinders of your engine, and the oxygen is just coming in from the air. But of course, once you're so for the bottom 10 kilometers, you maybe could do that. That's the idea of scramjets or something, where
That's
they were
right.
stuck in the air as they go. But once you're more than a few kilometers up, there's not much oxygen up there. So you actually need to carry the oxygen with you as well as the fuel, which adds to your weight.
That's right.
Worse.
That's right. It makes it a lot worse because you're not getting 2 times the amount of energy here. You're actually just getting the same amount of energy out, but you have twice the weight budget. And this is the thing that we have to start thinking about when we're talking about space travel. And in any case, it's all about weight, 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 and that weight is fuel.